Great. Well, hi, first of all. My name is Caleb Riggs, kind of Memphis's local 16-year-old space nerd. And whenever I say that, I always get usually one or of two questions, sometimes both. It's either, tell me about black holes, or tell me about aliens. And honestly, I would have done black holes, except there was a talk about that rather recently, and you can't really talk about that without getting into a lot of weird physics. And I don't really feel like having a slideshow full of weird physics, so here's aliens. The main thing about it is that the more we look out in the sky, the more modern we get with our viewing equipment, the more we realize the lack of where all of they are. With all of the Kepler exoplanets, with all of the weird comets flying by, like there was one, I'm actually not going to get into that, it's also more weird science and more biology than astronomy, so let's skip that for now. I can talk to it later. But yeah, we haven't seen anything yet, and that's terrifying in and of its own right. I'll get to that later though. But Arthur C. Clarke once said that there are two possibilities in this world. Either we are alone in the universe or we're not, and both are equally terrifying. That is the core of something called, it's cool, I like this thing, something called the Fermi Paradox. It's, in essence, aliens should be everywhere, but they're not. Why not? To start out, just some history to get it out of the way. It was named for a Nobel Prize-winning physicist and statistician named Enrico Fermi. And his paradox was defined as the clear disparity between the possibility of extraterrestrial civilizations and any actual evidence of their existence. So, putting it simpler terms, they should be everywhere, literally everywhere. The galaxy should be teeming with life, like Star Trek whizzing around, warp drive and all that, but they're just not. We haven't seen any. Why? Well, back up a bit. I say everywhere a lot, and I know that's a bit of a hyperbole, but there's this cool little thing. Fermi was actually famous for these things called Fermi estimates, and it's a dumb little statistics game where it's like how many piano players could be in New York, for example. They give you some numbers and you could have an average rate. Expand that to a galactic scale and you get how many civilizations, intelligent civilizations, should be able to see. And this guy, Frank Drake, made an equation for this, and it's more of a thought experiment than math. Because as you can see, the variables are defined as, we have the number of detectable civilizations equals star formation rate times the fraction of stars that form planets times the average number of habitable planets per star times the fraction of those planets that actually form life times the fraction of that life that actually becomes intelligent times the fraction of that intelligent life that is capable of communication times the years that civilization remains detectable. That's a lot. And you have to assume literally every variable in this equation. You can maybe get average rate of star formation. With the more exoplanets we find, we can kind of get that one more solid. But everything else, we have literally no idea. We have to assume almost every single variable in this equation. And that makes it very unreliable. But it's still fun as a thought experiment. For example, let me check the cheat sheet. Frank Drake and Carl Sagan did this early on when they first had it. And they got an answer of somewhere around 10. Per our galaxy. So there should be, according to them, 10 civilizations. We have seen 0. Other people have done it with some different numbers. There's been a very large range. For example, we have had 1. We have had less than 1 before. Yeah, it's mostly playing with that last value, the capital L, going back, the years it remains detectable. You can be as pessimistic with that as you like. But yeah, we have everything from 1 to being very generous with that capital L of 156 million. Yeah. And this also, seeing that number there, you have that and every single number in between, depending on how pessimistic of a person you want to be. Yet so far, we've only seen us. And still, why? Well, there's actually a lot of schools of thought on this, and I'm going to take a bit for most of this, or whatever time I have left, basically. I'm going to give you basically the big picture of a couple of the prevailing theories. Yeah, where is everyone? I forgot that was there. My bad. First option, again, being pessimistic, but don't worry, this just gets all the bad vibes out of the way. We're alone, and we always will be. Life is hard, and not like a teenage angst life is hard. It's biologically, life is hard. Scientifically, the conditions for life are very fragile, and it's very hard to maintain that perfect ratio of all this different chemistry that you need. For example, just on Earth, you needed a galactic habitable zone, the circumstellar habitable zone, a stable central star, and a planetary system, the right-sized terrestrial planet, the advantage of a giant guardian like Jupiter and large natural satellite to help stabilize our rotation, conditions needed to ensure the planet has a magnetosphere and plate tectonics, the chemistry of the lithosphere, atmosphere, and oceans, the role of evolutionary pumps like glaciation and rare large asteroid impacts, whatever led to the eukaryotic cell, sexual reproduction, and the Cambrian explosion. And that's just to get life off the ground. That's not even the intelligence part, which in and of itself is a very weird from evolutionary standpoint. That's also here nor there. You need all that just for life to get on Earth. That's called the rare Earth hypothesis. There's so much stuff that has to mesh perfectly that the odds, forgive the pun, are astronomical. There's too much stuff that can go wrong. Slightly more optimistically, but not really, there's these things called great filters. They're milestones that intelligent life have to pass in a certain amount of time, or else it risks just destroying itself. It can be everything. It can be getting from, just discovering fire and harnessing that to coherent speech to clean energy. It's all of these steps along the way that this civilization has to take in order to even think about getting to the stars. And the more and more we see that, we think that a lot of those filters could lead to a very probable idea that most intelligent life tends to destroy itself. It's not like we mean to, it's entirely accidental. We're seeing it now with climate change and all that. We haven't passed that clean energy hurdle yet, and that's a big threat to us right now. There's that, it could be natural. We remember what happened to the dinosaurs. It wasn't their fault, it was some dumb space rock. We could just piss off the wrong other dumb, slightly sentient monkey and yikes. Yeah. But enough pessimism. That's enough for now. I'm kind of bumming myself out. Maybe we're just here first. Who knows? The universe has been around for about 13 billion years. The first stars didn't take that much longer to form. The generation 2 stars that had all the heavy elements didn't take too much longer to follow. Life on Earth took about 4 billion years to get there. Maybe that's fast. We have no idea. The main problem with this is that we should have a galaxy full of statistical data points to draw averages from and draw conclusions and do all sorts of weird statistics like analyzation, that's what I'm thinking of. But we don't. We have a singular data point, and even that data point is kind of weird because it's us. And when you self-evaluate yourself, you're never all that honest, are we? I mean, come on, be truthful. You always like to see yourself in a better light than you actually are. That's just being human. So the stuff we have isn't very reliable. But I mean, maybe we're just fast on it. I don't know. On the opposite side, maybe we're late. Maybe we're just really slow. And using Earth's startup time of 4 billion years as kind of a benchmark, life could have started 9 billion years ago, 4 billion after the 13 billion that the universe was made. Assuming that's the answer, that's 9 billion years of evolution. Humans have only had like 200,000, less, maybe. Geologically, we're barely out of the trees. We literally just started. 9 billion years, geologically, is a lot more. 9 billion is such a big number, your brain physically can't imagine it and just shrugs it off as big number. Don't worry about it. So that being said, the life we could find we might not even be able to recognize it as life. It could be too alien. We have carbon-based life form here, and we're used to that. We need water and oxygen and all the stuff that carbon-based life needs. What if it's not carbon-based? It could be, what is it, silicon-based? That's a theory. We don't know what that will look like. It might not even be matter. It could be energy-based, photonically based. It could be weird, slightly sentient clouds of gas hiding in a nebula, and that calls itself a civilization. How would we be able to know? There's I can't tell if that little pocket of gas over there is making jokes at me. Maybe it doesn't like my talk. Maybe it finds all of my stuff I'm saying right now highly offensive, and if so, I'm quite sorry. Or maybe, for the Star Trek fans in the room, Dad, they have their own version of the Prime Directive. And you laugh, but that's an actual theory. We're literally not advanced enough to be worth an extraterrestrial civilization's time of coming down and saying hello, because we haven't quite reached that point yet. They still see us as, they fight a lot, and they still haven't fixed their problem of not using coal anymore. And, they still have weapons of mass destruction constantly turned on themselves, threatening to press the button no matter how big it is at any point. We'll give them a couple hundred years. We'll check back in a bit. Yeah, that's pretty much all there is to that. Number 4, this is actually the stance Stephen Hawking takes on it. Same thing with AI, too. It's just too dangerous. We all remember what happened when Columbus came to the New World. Didn't go well for the natives at all. There's actually an interesting book. It's 1491. I forget the author. I haven't read it myself, but I've heard enough of it, where it turns out that before Columbus came along, the natives actually had a very advanced society. They had trade routes going tip of South America all the way up to Canada. They had stuff that rivaled, if not were better, than the European technology. But then Columbus came along and brought all these diseases and plagues and all that kind of stuff, and it just decimated everything. So that by the time the actual colonists came along and the actual historians came along to study them, it was only not even a shadow of what was once there. It was pitiful. And that's only because they didn't know what the flu was. They didn't have anything to fight that. It was not their fault. And this is what could happen. We could be the natives with a brave explorer Columbus alien coming down to us. Or it could be the other way around. We could have some space bug that humans have just adapted to evolve with and be completely fine as living inside of us. Who knows? Maybe they're deadly sick to the flu, and we just don't know. He could go back to his home planet and not knowingly infect everyone on there, and that species would be dead. Or it could be the other way around. He could come down not knowing he has some sort of superbug, and our species would be dead. I'm sorry, I thought I'd skip the pessimism. Apparently there's more. Apologies. It's, God. My personal favorite, it's all a conspiracy. Aliens have been here from the very beginning, messing with human history. Have you seen Ancient Aliens? Have you seen the X-Files? Have you seen Roswell, New Mexico? They're all here, and it's all the government covering it up. It's the man not thinking we have what it takes to take the truth, man. I want to know what happened. I want to know what happened. Look it up. Flat Earth, the moon's not real, Finland is a statistical improbability. It's all fake. It's all the government. Where's my tinfoil hat? You lie. You laugh, but the funny part is that this is not a joke. This is an actual answer to this, put forth by actual scientists with, actual reputable degrees and who know what they're talking about. All jokes aside, there's actually something called the Men in Black hypothesis for this. There is legitimate thought that there is some sort of government black ops agency, call it Area 51, call it whatever you want, that is frequently in contact with extraterrestrials, and they just don't think the general public can handle it. More on conspiracy theory lines, the Hall cameras outside of the International Space Station that look out into Earth, they go down from time to time, and that's just because, signaling range and all sorts of things that can happen when you have a rather delicate piece of equipment duct taped to the side of a large space station in the vacuum of space going at hypersonic speeds. But no, some people think that that's because the cameras go down when an alien UFO is in view of the camera. Right? That's just crazy. Or is it? Come on. Oh, right. I have all sorts of proof. Like that right there. That one right there. Look at that. Look at that. Look at all that. That's you can't argue with that. You just can't. It's impossible. They're coming for you. Little green men from Mars, Another thing. Less jokey now. Sorry. I like comic relief. Everyone's listening, but no one's broadcasting. This one gets a little complicated, honestly. Because we have organizations like SETI. We have organization like SETI. There's really nothing else out there that's listening all the time. They have huge radio telescopes pointing out somewhere into space, hoping they find something. But there's nothing specifically broadcasting out into space. We just have our stray radio signals going out there, not really directed at anything, just chilling out in space, and we've had that for about a century now. And I mean, even if we did find someone with the radio telescopes, what would we do? It would be a planet-wide event, seeing as this is something the species would have to consider. And a lot of our species, wow, I need to stop with the pessimism, but a lot of our species is kind of bent on not working together. A lot of people are still wrapped up in, this piece of land is mine, or I want your oil. No, I'm not trying to make shots at anyone. But it would have to be something that it's a global thing. It'd have to be teamwork on a global scale that's just unprecedented by anything. I mean, the International Space Station has kind of laid some of the groundwork for a big international event in space. But this would have to be a global thing, and just the global politics for that are nothing. And back to the other point, these two plaques are on the Voyager and the Pioneer probes that are the only man-made objects to have left the solar system. And they're carrying these plaques that have, like this one over here, it has human physiology with the scale of the actual probe. It has where it came from, and it has some very weird scaled thing of all of these points are stars, and they all come back. Wait a minute, I have this thing. Haha! They all come back to that point right there. That's supposed to be our star, like a little map of our neighborhood, so that whoever finds these plaques can come back and find us and trace it to its owner. But they haven't actually gotten very far in the grand scheme of things. It's, I think, like just recently past outer solar system and out into legitimate interstellar space. And even then, that's not very far. The closest star is like 4 light years away. It would take them a lot to get there. They're not even going close to light speed. Like, God, it's a lot. Next up, because that's weird. Back to distances. They're everywhere. They're all sorts of places. They're hiding around every nook and cranny, but they're just too freaking far away to do anything about it. Going back to an earlier point, we've been sending stray radio signals for about a century now. So that means, give us a 100 light year sphere of stars in there that could have maybe, big maybe. Radio signals disperse a lot in space. They lose a lot of strength. They could be mistaken for the background noise very easily. But maybe someone's smart enough and picks us out towards the edge, and they send a signal back. Well, if you have 100 light years out and then 100 light years back, that's 200 years. That's 100 more years of waiting for that one signal. Now maybe we want to get a little quicker. Let's half it. Let's have 50 years. 50 light years. So that way we could theoretically be sending the signal back to us right now, because that's 50 out, 50 back. That's 100 total. That makes sense. And with the more we get the exoplanets out there, and the more of them we find, the more of them that are actually around there their star's habitable zone, like, what was it, the TRAPPIST system? I want to say that had like 7 planets total, and 3 of them were in that perfect Goldilocks zone for liquid water. That is, if we want to find life like us. The more we find that, the more we realize there are a lot of planets out there. That's just driving the statistical odds of we should be able to find something. We should be able to get a signal back. That's just drives it up and up and up and up and up and up all the way. Do I have a pointer on this? Yes, I do. All the way up there to the ceiling. Yet we don't have anything. We have literally nothing. Where is everyone? We don't know. Everyone's just too freaking far away. And even if we did find one, what would we do about it? We could send a signal back, maybe, and just be like, oh, hey, how's it going? What's your species like? Do you still eat peanut butter and jelly sandwiches? We could send it back. Let's put them 50 light years away. Yeah, let's be nice. It goes 50 light years away. They get the signal. They have to translate whatever language we send it in into whatever language they speak, which would be very strange because they would have no other basis of comparison. But assuming they are able to translate and get a response, 50 light years back to us, that's 100 years. That's the grandchild of whoever sent the message getting the message back. We're impatient. We want it quicker than that. But that's the speed of light. Current physics says that's literally the fastest we can go. The fastest man-made object we've ever had, say, we want to send like a sample of dirt or whatever, I don't know, whatever scientist samples want to send. The fastest man-made object we've ever sent was the Juno spacecraft going at 25 miles per second a little bit, which is pretty fast. I mean, granted, that's pretty dang fast. The closest star, again, is 4.2 light years away. That is 2.47 times 10 to the 13th miles. Divide that by 25. It still takes 31,000 years for Juno to get there. That's a bit more than your grandchild. That's like ancestry at that point. There's just no way for us to get there in time. Of course, there's all sorts of weird propulsion ideas. There's the, what was it, Alcubierre drive, Orion drive, generational ships. These could all fix it. I say fix it. But I'm impatient. I want it to happen now. I'm 16. I want everything now, 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 now. But it just can't. Although it should. There should be everyone. We should have been able to find someone a while ago, right? But we haven't. And there's just no point. Or is there? I don't know. This is kind of the end of it. But I feel like the one major question in astronomy that everyone expects us to answer, everyone needs the answer of, are we alone in the universe? Every time you look up at the night sky and you see all those thousands of stars up there, and you always pick out one star. You pick out that bright star and you wave at it. Because maybe someone's waving back. I don't know. Why don't we know? Look at all this stuff. Look at, I mean, sure, there's all these ideas. But what do they add up to? I mean, oh, it just makes me laugh in like a really annoyed kind of way. Because honestly, it's my generation that's going to have to deal with this next. Thanks for that, by the way. And we have a lot of work cut out for us. Because they should be everywhere. But they're not. Questions? Yes.